Hi everyone, in this video we're going to go through 10G, families of functions. I'm going to do the majority of it with the calculator just because to do it by hand will take ages, and I've already gone over all the skills you need to do it by hand, so I'm going to do it on the calculator. I encourage you, if you don't know how to do it by hand, to attempt the question doing it by hand. But with these questions, it's not so much the skills of finding the derivative or finding the stationary point. It's just going a little bit deeper and being able to understand these types of questions. All right, so question 1. I'm going to do all 10 questions, so it's going to be a long video. Just fast forward it. I suggest you do the questions on your own. Check your answers or your solutions with the textbook. And if you get stuck, you can just fast forward to whatever question you need help with. Probably save you a bit of time, but if you really want to, you can listen to the whole video and work with me as I work through the questions. All right, so I can't remember whether I read out the question, but anyway, question 1, consider the family of functions with rules f of x, blah, 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 where b is greater than 1. So remember, it's always important to take note of any conditions on variables. So b has to be greater than 1, which is important when we do some questions later on. Okay, so question A, find the derivative of f of x with respect to x. So you've got your function here, and some people would go ahead and maybe use the product rule, which is fine, but I would actually expand x minus 1 squared and then find the derivative. And then expand it again and then find the derivative, which might be a little bit, actually, I don't know whether it's going to be any easier. But we're usually using the calculator, so I'm just not familiar with where everything is. Actually, if we get the keyboard up, all I want to do is define, there we go. So we're going to define f of x. All right, so just give me a bit of time while I type it all in. X minus b. Okay, so we've defined f of x, and so now we can find the derivative. So we want f dash x. Oops, it's not going to do it for us. Let's do the derivative. Okay, so there's our derivative of f of x. So I'm still getting used to notation of the calculator, and sometimes I know there's probably quicker ways to do it than what I am doing it. So there's your derivative of f of x, so 3x squared minus 2bx minus 4x plus 2b plus 1. All right, so we found the answer to A, the derivative of f of x with respect to x. Now what I am going to do is I'm going to highlight that and copy it, and I am going to factorize it. So just got to figure out where factorizing is. There we go. Type that in. All right, so now it's in factorized form. Now the reason why I factorized it is because it's going to help us with question B. So I'll do that in a sec. Let me just write down the answers first. So for question A, we had to find the derivative, f dash x. All right, so I've got it in expanded form and then I factorized it. So I'm going to write the factorized form down and see how quick and easy it was to do on the calculator. All right, so you can always check your answers if you've got your calculator with you, or you can use your calculator. All right, so question B, find the coordinates of the stationary points of the graph y equals f of x. So remember your stationary points are when your derivative or your gradient function is equal to 0. So what I can do now, and I could have done it before actually, is let me just go to solve. Now I've got to find, there it is. All right. And we want that to equal 0, and we're solving for x. So I probably didn't need to put it in factorized form. So if you wanted to let it equal 0, so basically x minus 1 times 3x minus 2b minus 1 is equal to 0. So using the null factor law, that means x minus 1 has to equal to 0, or 3x minus 2b minus 1 has to equal to 0. So that's how we get x equals 1, and we can see that on the calculator. Or x equals 2b. Now, they've put it as two separate fractions, but I'm just going to put it as one. So do 2b plus 1 over 3. All right, but we had to find the coordinates. So we've got x equals 1 and x equals 2b plus 1 over 3. So again, on the calculator, oh, I don't know why it went all the way down there, sorry. I should have typed f on the calculator. So on the calculator, we want to work out f of 1. So that's 0. So when x equals 1, f of 1 is 0. So the first coordinate is 1, 0. And when, now this is, oh, I did it again. Sorry. There we go. I've got to press on the calculator before I do anything. All right, so what we can do is just highlight this and drag it down instead of having to retype it again. So just make sure I've put that in correctly. Oh God, I don't like that at all. Anyway, I'm going to have to like it. So when x equals 2b plus 1 over 3, y, so all I've done is substituted that in, 2b plus 1 over 3. And remember, you're substituting it into your original function, not your gradient function. All right. Oh God, I don't like this. So I'm just going to leave it as it is though, 2b minus 2 over 3 squared times b minus 1 over 3. So they're our coordinates. You could expand that. Let's see what happens when we expand this, because it's currently in factorized form. Oh, something coming up. No? Let's try again. There we go. No, it's not any better. All right, we're just going to leave it like that in factorized form. Okay, so we've found the coordinates of the stationary points of the graph. Okay, so we know one is at 1, 0, and the other one is at that horrible coordinates with b in it. All right, show that the stationary point at 1, 0 is always a local maximum. Okay, so question C. All right, so when we're used to finding the types of stationary points, we know we have to do a table. So let me just quickly do one here. So we know that there is a stationary point at x equals 1. So that is a 0 gradient. So we could do what is happening before 1, but the problem is here, we can't really put a value in because the value of b has to be greater than 1. So effectively what we're going to have to do is kind of think, well, let's just see what is happening before the number 1. And then because of the way the function is written, so it's x minus 1 squared, we know at the point 1, 0, we're going to have a repeated factor. So the fact that it's a repeated factor makes it either a local minimum or a local maximum. This question I actually paused on and did quite a bit of work to explain why you, or think about why you couldn't put a value greater than 1 on there. And that's because of b. okay, the variable b, because b, we don't know what it is. Okay, so you'll notice if you put the number 2 there, you're going to get a positive gradient, but if you put the number 4 there, you're going to get a negative gradient. So let's just have a look at what's happening at 0. So we're going to do our, okay, so I press the black pen and it comes up red. All right, so we're going to do the gradient function at 0. So I've already done that on my calculator. All right, but I'm going to do it again. So just ignore all the other stuff that I've done. Oops. No, we want the derivative. So let's go back up. Oh, so many things on here. Let's quickly. Come on, where are you? All right, so there's our derivative. So we could use it either in expanded form or factorized form. So I'm just going to copy that. Let's go down. All right, so we've got, given that x is equal to 0, and we get 2b plus 1. Now we know b has to be greater than 1, all right? It says that in the question. So your gradient at x equals 0 is always going to be positive. All right, so it's going to be a positive gradient. So that means on the other side of 1, no matter what the value is going to be, it's going to have to be a negative gradient. So that means the point 1, 0 is going to be a local maximum, and just because it's a cubic means that the other point, and I'm not going to write it all down because it's very long, is a local minimum. All right, so show that the stationary point at 1, 0 is always a local maximum. All right, find the value of b if the stationary points occur where x equals 1 and x equals 4. So we know that x equals 1 is already the point 1, 0, but when x equals 4, I'm going to put that down here. Okay, so we're going to use the coordinates of the other stationary point. Okay, so we had that up there. And when I was checking the answers with the textbook, we only need the x coordinate because x equals 4. They actually factorized this into a cubic, so probably could have factorized it a bit better. But anyway, so let's solve this. So solve, and then we've got, and we're solving for b. We could put x in if you want. But the problem is if I do type in x, sometimes students copy it as an x, and then if you did that on the exam, you would get it wrong. So you don't really want to do that. All right, so b is equal to 11 over 2. Can't remember what we had to do. Sorry, find the value of b at the stationary points. All right, so 11 on 2. Cool. So I was just making sure that that was actually correct. Okay, so let's move on to the next question. Okay, yep, so there's only one value of b. So question 2, if I just move that over so we can see the whole question. The graph of the function y equals x to the power of 4 minus 4x squared is translated by a units in the positive direction of the x-axis and b units in the positive direction of the y-axis, where a and b are positive constants. Question A, find the coordinates of the turning point of the graph x to the power of 4 minus 4x squared. Okay, so we don't have to do anything with the transformations just yet. We're just finding the coordinates of the turning point of the graph x to the power of 4 minus x squared. Now this one here isn't going to be too hard to do by hand. All right, so we've got y equals x to the power of 4 minus 4x squared. All right, so we need to find, if we're finding the turning points, they're stationary points. So dy dx, remember dy dx and f dash x are the same thing. So we're just finding the derivative. All right, there it is. If you want to do it on your calculator, you can. So the turning point is when dy dx is equal to 0. So 4x cubed minus 8. Thought I missed a power there. No, I didn't. Is equal to 0. All right, so we need to take out common factor, which is going to be 4x. And we're left with x squared minus 2. So using your null factor law, x squared is equal to 0, or x squared minus 2 is equal to 0. So x is equal to 0, or x is equal to plus or minus the square root of 2, if I was to do all that in several steps. So we've got 3 turning points, and we've got to find the coordinates. This is where it gets a bit annoying. All right, so we've got one turning point at 0, 0. That's a nice easy one. All right, and you could do this on your calculator if you wanted to, but when x is equal to root 2, we're going to have y is equal to root 2 to the power of 4 minus, I'm going to run out of room here, 4 root 2 squared. All right, if it helps, put instead of using the square root, just use the power of a half times 4 minus 4, 2 to the power of a half, 2. And then you multiply your powers. So we're going to have 2 to the power of a half times 4, which is 2. And then minus 4 times 2 to the power of a half times 2, so half times 2 is just 1. So we're going to have 4 minus 8, which is negative 4. So the other point, I might just write them all up here, is root 2 negative 4. Now, I would, to save time, I would just have a look here. If I was going to have negative root 2 substituted in, because my powers are both even, the negatives are going to cancel each other out. So my other turning point is still going to be, at y equals negative 4, because substituting in negative root 2 is not going to make any difference. All right, for question B, we're finding the coordinates of the turning points of its image. So what we're doing is let's get my highlighter going, A units in the x-axis and B units positive direction of the y-axis. So we're going basically x plus A, x plus B, and I'm going to write it up here just because I've got all my coordinates up here, which is probably not ideal. Actually, I'll rewrite them. Okay, so question B, so our turning points are 0, 0. I can easily remember what they were, and negative root 2, negative 4. All right, so our transformations, so xy is now becoming x plus A, y plus B. All right, so basically we don't know what A and B are, but we're just adding them to each one. So for this point here, it's going to become 0 plus A, 0 plus B, which is just going to become AB. All right, for this next point, we're going to have root 2 plus A, negative 4 plus B. And then for this one here, we're going to have negative root 2 plus A and negative 4 plus B. So they're the transformations of the points. All right, moving on to question 3. So a cubic function has the rule f of x equals ax cubed plus bx squared plus cx. The graph has a stationary point at 110. So this point 110 is extremely important. So even though it's just 1 point, we can actually get 2 equations from it. Because first of all, this point here is a point on, can't talk properly, on our graph. And it's also our stationary point. So when we're trying to find our equations, so remember we've got 3 unknowns, we need 3 equations, but it's just saying find A and B in terms of C. Okay, so if I substitute in f of 1, so x equals 1, and that is equal to 11. So let's substitute that in. So we've got a times 1 cubed is just a, b times 1 squared is just b, and c times 1 is c. So I know that a plus b plus c is equal to 11. Okay, so there's one equation. You can call that equation 1 if you like. And then the second equation, because we know it's a stationary point, I just go ahead and find the derivative, which is not too, even though it's in terms of a, b, and c, you just treat it as a, b, and c as if they were numbers. So we're going to have 3ax squared plus 2bx plus c. Now it's a stationary point at x equals 1. So f dash 1 is equal to 0. So substituting in x equals 1, I'm going to have 3a plus 2b plus c is equal to 0. And there is my second equation. So I've got my two equations, and you can, if you want, we're finding a and b in terms of c. So what you can do is put them into your calculator and press solve. Use solve, or you can solve them by hand using simultaneous equations. I would use the elimination method, but I'm just going to do it on the calculator for now. So if we go to, actually, I think this is what someone did the other day. Oops, not that one. Actually, I think it was. Let's just see. So on the old calculator, we could just do solve and then press and in between each equation. I don't know what to press here. Can I do A, B like that? No, I don't. I'm going to press pause first. Alright, I realized I was pressing the wrong button. So I wanted to press this one here, whereas I was pressing this one here. Okay, well, it's just gone a bit crazy. So what I did, if I just scroll up on my calculator, alright, so here I was solving for B, and it gave me B but in terms of A. And then if I solved for C, it gave me C in terms of A. And if I solved for A, it gave me A in terms of B. So it's not giving me B and A in terms of C, all right, on my calculator. So you could still do it by hand, but I'll show you how to manipulate it on your calculator. So if I get C is equal to A plus 20, so remember we want the value of C, find A and B in terms of C. So if C is equal to A plus 20, that means A is equal to C minus 20. And then I can just go back to my answer for B, which is B equals negative 2A minus 10, and then just substitute in A there. So B is equal to negative 2C minus 20 minus 10, and I get B is equal to negative 2C plus 40 minus 10, and I'll just scroll down a bit more, and I get B is equal to negative 2C plus 30. All right, so just having to play around a bit with what you get in your calculator to get A and B in terms of C. All right, sorry, it took me a bit of time to figure out which button to actually press on the calculator. All right, and by the time I did that, it probably would have been easier to do it by hand. So doing 1 and 2, simultaneous equations using the elimination method wouldn't be that difficult to do. Okay, so question B, find the value of C for which the graph has a stationary point at x equals 3. Now I totally forgot what the question was asking. Okay. All right, so we found the derivative earlier, which is here. Let's go back up. And we're just going to substitute in x equals 3. So let's just do that down here. Um, 3ax squared. Now x is 3, so I'm just going to substitute it in now. 3ax squared 2bx. All right, and we know that has to equal 0 because it's a stationary point. Now, the reason why we've got in the previous question a and b in terms of c is now I can substitute them back into the equation. So instead of having 3 times a, I can just write 3 times c minus 20. And then I've got 3 squared, so we can times by 9 as well. Probably should have tidied up a bit before I did this, but anyway. Times 3 plus c is equal to 0. Okay, so we've got 27. So, oh gosh, this is where it would be easier to do on the calculator. All right, I'm going to pause it and just quickly write it. All right, so you do end up with 45 on 2 if you want to write that as a decimal. That's perfectly fine because you do have terminating decimals, so it's 22.5. I just wanted to, I didn't fix this up before and I did realize it when I paused my video that I did 11. It should have been 10, so I might just quickly change that here. Hopefully you pick that up. Is it going to be an issue? I don't think it's an issue anywhere else. So, because I did it on the calculator, but I typed it in. Oh, that's a terrible 0. Oh gosh. Yeah, I typed it incorrectly in the calculator, so it's all good. 0 and 10. Okay. All right, so there's all the working out to get the value of c. So we wanted find the value of c for which the graph has a stationary point at x equals 3. All right, let's move on. It's going to be a long video. All right, might stop after question 4 and do a second video. All right, consider the function blah, 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 where a is a real number with a is greater than 0. So that is extremely important. A is greater than 0. And we've also got a domain here, 0 to infinity, which is important. All right, so that's a restriction on your x value. It's got nothing to do with a. Okay. All right, determine the intervals on which f is strictly decreasing function and the intervals on which f is strictly increasing. All right, so we need to deal with the gradient function, okay, because strictly increasing and strictly decreasing do refer to the gradient. So I'm going to find my derivative first, and it's not a hard one, so I'm going to just quickly do it by hand. So 2x minus 3ax squared. All right, so if it's strictly decreasing, we'll do strictly decreasing first. So we want the gradient function to be decreasing and we want it less than 0. So I'm just going to do it on the side here. So 2x minus 3ax squared has to be less than 0. And then you're just solving for a. Sorry, you're not solving for a, you're solving for x in terms of a. So let's take out x as a common factor. So we're going to have 2 minus 3ax is less than 0. All right, and we divide both sides by 0, we're going to be left with 2 minus 3ax is less than 0. Negative 3ax is less than negative 2. All right, let's keep going. Let's divide both sides by negative 3a. So that goes, and because we've divided by a negative, our inequality sign has to change direction. So x has to be greater than 2 on 3a. All right, so if we were looking at, sorry, let's go to, what do we have? The intervals. So x is between, starting at 2 on 3a, and it's not including that value, but to infinity. All right, so from 2 over 3a to infinity. All right, so that's where it is, what was it, strictly decreasing. I might just write that here. So that means on the other side of 2 over 3a, so that means 2 over 3a is going to be your maximum. So want it less than, and remember your domain is from 0. Actually, I need to change that to including 0. I'm pretty sure in the question it is including 0. So from 0 to 2 on 3a, we are strictly increasing. I don't know why I've gone all the way on the right-hand side of the page. Okay, find the equation of the tangent to the graph of f at the point 1a, 0. All right, so again, we're using the derivative. So I'm going to write that again. And we want it at the point 1 over a. So I'm going to substitute in 1 over a. Just make sure you're substituting for x, not a. All right, so we've got 2 on a minus, so going to be 3a on a squared. We can just simplify that a little bit. So 2 over a, so we're going to have 3 over a. So we're going to have 2 minus 3 on a, which is going to be negative 1 on a. So remember what we've just done there is found the gradient. So because the tangent line is a straight line, obviously. So we want to get it in the form y equals mx plus c. All right, so we've just found the gradient. We've got the point. Okay, so it gave us in the question the point was 1a, 0. So m equals negative 1 on a, and your point xy, so x is 1 on a and y equals 0. So we just substitute them all into y equals mx plus c to get the value of c. So we're going to have negative 1 on a times 1 on a plus c. All right, so we're going to have 1 times 1 and a times a. So we're going to have negative 1 on a squared plus c. So c is equal to 1 on a squared. So your equation of the tangent is y equals your gradient, which is negative 1 on a, x, plus 1 on a squared. So that's your tangent equation. All right, so part C, we're looking for the equation of the normal. So remember the tangent and the normal are perpendicular to each other. So the gradient of the normal is just the negative reciprocal of the gradient of the tangent. So let's just go back down. Very long question. All right, so we're doing question C. We want to do the normal now. All right, so the gradient of your tangent was negative 1 on a. So that means the gradient of your normal is a negative reciprocal. So we turn the negative into a positive and we flip the fraction. So it's just going to be a. We're still doing it at the same point. So x is 1 on a and y is 0. So same thing as before, we substituted into y equals mx plus c because the normal is also a straight line. And we're just solving for C. So I'll just go down. So y is 0. Your gradient is A. X is 1 on A plus C. So we're going to have A on A. So C is equal to -1. So our normal equation is y equals AX minus 1. All right, question D, we're doing the range of F. So we've got here a cubic. Okay, it's got a defined domain. So we looked before at when it was strictly increasing and strictly decreasing. So we know that the point 213A, up until that point from 0 to 213A, it's strictly increasing, and then after that it's decreasing. So if we were to just draw a graph, and I can easily do that here. All right, so, and remember that A was greater than 0, so, or positive. So we've got 2 on 3A somewhere there. So up until that point, and now we don't have to draw the cubic, we just know up to that point it's increasing, and then it's decreasing. So this point here, we just need to substitute in the X coordinate to get the Y coordinate. Does that make sense? So and then your range is, because we're going all the way to infinity. Sorry, I know you can't see my cursor. So we're strictly decreasing to infinity. So this value here is going to keep going, basically. Whoops, it's not the best. All right, so our range, let me just do it over here. We're going to start at -infinity, okay, because we know that it's strictly, oops, sorry, let me just go, yeah, strictly decreasing from 2 over 3a to infinity. So it's going to keep going. So our range is going to be -infinity up to f of 2 on 3a. So we're just, sorry for going all over that, but I'm running out of space. So you just need to substitute 2 on 3a back into your original function. Now, because I'm running out of room, I might just quickly do it on the calculator. So, 2 on 3a. Now, I would like to put that in brackets. That's what I was trying to do before. Squared minus a times, oh, do you know what? I'm going to do this in an easier way. So x squared minus a times x to the power of 3. Now, given that x is equal to 2 on 3a. Be better. Oh, I don't really like how it's no. Let's see if we can factorize it. I probably should have highlighted it first. Just give me a sec. No, it's not much nicer. All right, I think I know what the calculator has done. So let's just go back. I'm going to highlight that and, oh, didn't paste it. Okay, so let's just see if I've picked up where the error has happened. So I'm pretty sure I did press times. Now, the problem I know with the other calculator is if you wrote AX, it just sees it as one variable AX instead of two A times X. So there we go, that's a bit better. And I should have picked that up because X was still in our answer when we were substituting for X. So just something to be aware of. If you are writing it that two letters next to each other, you should be putting a multiply sign in. Okay, so there's our Y coordinate. So our range is from, oh God, in there. I think my computer also, I'm going to have to stop after this question because it keeps glitching. All right, so we're going from negative infinity. Why am I writing F again? Sorry. So not F of 213a, but actually what it is when we substitute it in. So 4 over, and I'm getting this from my calculator if you're wondering where it's from. Okay, so that's your range. All right, I'm going to stop the video there just because my computer's glitching and I've also been talking for a long time. So in the next video, I'll do maybe the rest of the questions, maybe do them over 3 videos. Anyway, all right, bye girls.